In this video, I'd like to talk about the math question of the day for February 11th, 2023. And for this problem, we need to solve for the variable x in this square root equation or this radical equation. And to solve a problem like this, you need to have a solid understanding of solving equations from Algebra 1, but also you will need to understand Algebra 2 since these radical equations are generally taught in that class. So at this point, go ahead and pause the video, see if you can work through this on your own, and when you're ready, we can start going through this together. Now, assuming that you have attempted the problem, we can start going through this together. And if you do have suggestions for future videos, go ahead and leave them as a comment down below. So when dealing with these radical or square root equations, the general strategy, especially if there's just one square root, is to isolate the square root term and then square each side. So we can start by adding x to each side of the equation so that we can get the square root term by itself. So we get 7 plus x is the square root of 39 plus 3x. Now at this point, to cancel out this square root, we need to do the inverse operation to that. We need to square each side of the equation, since square roots and squares typically cancel each other out. So let's square both sides of the equation, and the square root squared, those will cancel, and we will just get back 39 plus 3x. And on the left-hand side, we'll have to multiply this out. We get 7 plus x multiplied by 7 plus x. Now, one unique property about these square root equations is that sometimes we end up with extra solutions, or what are known as extraneous solutions. And those are solutions that don't actually solve this equation. In fact, we may end up with a solution for this equation if I put a negative here. And we need to be careful with that. And the reason we might end up with a solution that doesn't actually solve this, but instead solves when there's a negative sign here, is this step right here. When we square both sides, notice that if this was negative, we would still get the exact same equation here. Nothing would change. Since we're multiplying a negative by itself, we would end up with a positive answer. So we need to be careful. Sometimes we will end up with a solution that doesn't actually work here, and that's called extraneous, an extraneous solution. And that solution essentially just comes from this other equation where there was a negative sign in front of the square root, and when everything was squared, that negative went away. So either situation you have where this is positive or this is negative, they both lead to the exact same equation, so we need to be careful with that. But with that in mind, we just need to plug our answer back into the equation at the end to see if it makes sense. So let's finish working through this. We can distribute here to actually multiply this out. We'll get a quadratic expression. We get 7 times 7, which is 49. 7 times x, or 7x, plus 7x. So that's plus 14x. And then x times x we know is x squared. And since we have a quadratic, we can solve this by setting one side of the equation equal to 0. And let's just move everything to the left side. So let's subtract 39 and subtract 3x on each side of this equation, so that now we have, and I'll write the x squared first, we have x squared plus 11x, and this becomes plus 10. All of this is equal to 0. And this looks like it could be factored. So let's try to factor this. We can rewrite this as a product of two binomials where we know the first terms in each of these have to be x, since when we remultiply it out, they will distribute and we get x times x, which is x squared. And these two terms here, these are going to be numbers or constants, but we know when we multiply these together, we get 10. So we need to think what numbers multiply to 10. That could be 5 and 2, minus 5 and minus 2, or 1 and 10, and minus 1 and minus 10. Now, to decide which of these pairs it actually is, we consider our last point here, and we just need to think which of these pairs actually add to positive 11. And that looks to be 1 and 10. So we get x plus 1 and x plus 10 here. And you can, of course, check this by just redistributing and seeing that you do get back this quadratic expression. Now, if it wasn't factorable, we can just use the quadratic formula. But in its factored form, it's fairly easy to solve this. We use our zero product property. If either of these factors is 0, then you have 0 times something, which is 0. So one solution would be -1. This would make this factor 0, and 0 times by 9 is, of course, 0. We can also use the value of -10. Since this becomes 0 and this would become -9, but 0 times anything is 0. So these are two potential solutions, but again, the problem is one or both might be extraneous. So we need to plug these in to see if we actually get something that makes sense. And if you want, you can even start with this arrangement of the equation before we squared everything, since again, it's that squaring process where we end up with those extraneous solutions. So if we want to look at the 7 plus x is root 39 plus 3x instead of the original, that would be fine as well. But at this point, we just need to plug in what we think are the solutions. We have x is -1 and -10. And let's start with -1. We plug that in. We get 7 is the square root of 39 plus 3 times -1, or just -3. And all of this would be minus x. And x is -1, so we'll be adding 1. Well, this is the square root of 36, which is 6. And 6 plus 1 does equal 7. So -1 is a solution. That one does work. But let's try -10 now. If we do 7 is equal to root 39 plus 3 times -10, or 39 minus 30. And then we have minus x, but x is negative, so we are really adding 10 to that. And at this point, you can immediately see that there is a problem because square roots can't be negative. So we have 7 is equal to something plus 10, but this would have to be -3 for this to make sense. But we know this is a +3. 7 is 3 plus 10, which does not work, meaning that -10, this is an extraneous solution. In fact, this is the solution for the equation where we have a negative out front. And you can see that would be true because in this step right here, this would be negative and we'd get a -3, and then it would be true. But we don't have that. We have the positive case. And again, this just comes from the fact that if this was negative, then when we square everything, we cancel out that negative and we end up with this equation here, which is the same that we got when this was a positive value. So with these square root equations and equations in general, it is necessary to check your solution if you want to be confident that you actually got the right answer.